Okay, one theorem we're going to look at, intermediate value theorem. This theorem says if you have a continuous function f on a closed interval a to b, let n be some number between f of a and f of b. So let's look at a picture here. We have a continuous function here, as you can see. It's from the interval from a to b, okay, because that's the starting value and ending value here, and it's closed. They're saying n is some number between f of a and f of b. Remember how you find f of a is if you follow this up and go over, there's our f of a. If we follow our b up, that becomes our f of b. N is some number between those two values. So what this is saying now is as long as f of a and f of b aren't the same thing, there exists a number c somewhere in between a and b such that f of c is equal to n. So they're saying somewhere between this value and this value, there has to be a c that if you follow it up to the graph will give you that value n. Here's another way to kind of explain intermediate value theorem. If we know that this is a continuous function, there's no breaks, and we have a point here and a point here, and n is some y value in between, is there any way for us to draw this line where we don't go through that n at some point? No, we have to. The only way to not cross through this y value would be for me to somehow get here, pick up my pencil and do that. But by doing that, now this isn't continuous anymore, and we have to be continuous for this theorem to work. So if you have a continuous function, it's impossible not to pass through that y value at some point. Now it may be, if you look at the second graph, it may be that we pass through multiple times through that value, but we're guaranteed to exist. They're guaranteed to exist at least one spot. It might be more than one, but for sure, absolutely has to be one value. This can help us establish and find stuff such as this problem. It says let f of x be this function. Show that there is a number c such that f of c equals 0. So this is f of c, remember that's our y value. So if we're looking at the graph of this, they're saying this graph at some point crosses through our x-axis because that's where y equals 0. So we have a graph, or we have this graph has to cross through at least once. So if we're going to show that, we have to figure out, can we show that there's a point somewhere below down here and a point somewhere above up here? And if we do that, then we can establish that it has to go through the value in between, because this function right here is continuous. We talked about polynomials are always continuous, and this is a polynomial here. So let's see if we can figure out a value that gives something less than, or that be negative. I think an easy one to see right here, if we were to plug in 0, we can easily see that putting 0 in here, that's going to equal 0. This term will equal 0, because anything times 0 is 0, that term's 0. And so f of 0 is equal to -2. So we've established there's a point right here. There's a negative value of this graph. Now if we can show some value up here, we can show that has to pass through. So we got to find something that we can put in for x that will come out bigger than 0. I don't think 1's going to get us there, but I think if we go 2, let's find f of 2 here. So if we put 2 in here, we got 2 to the 3rd power would be 8. 4 times 8 is 32. 2 squared is 4. 6 times 4 is 24. 6 minus 2. Adding that together now, we got 32 minus 24 would be 8. 8 plus 6 is 14. Minus 2 would be 12. So we see that at 2, there's a value up here at 12. So if this is a continuous function, here again is here's our f of c has equals 0. Is there any way to connect these with this being a continuous function that I don't go through that line? Nah, there isn't. So what we can do now is use intermediate value theorem to say that. So what we can say is by intermediate value theorem, there must be, oh, sorry, must be, there must be a place where f of c, I guess we don't need the in there. There must be f of c equals 0 somewhere in between, or where that c value, that's our x value, somewhere in our closed interval here. This is from 0 to 2 here was our ordered pairs of this. So in between 0 and 2, there must be a f of c equals 0 somewhere in the x range of 0 to 2, and I suppose we should close that off, where I'm going to rephrase this. There must be a c in this value where f of c equals 0, because f of c we know is going to be between 12 and this value came out to be negative 2. So because 0's in between there, it has to pass through there by intermediate value theorem.